This video will show you how to correctly solder the PCB you designed in Fusion. First, use tape to secure the PCB so it doesn't move around when soldering. Place the USB-C connector on the bottom side of the PCB and ensure the 4 metal tabs set in the slots. Since the USB-C connector has a lot of metal which will act as a heat sink, we'll need to use a large soldering iron tip to allow maximum heat flow. We'll also want to use a thick solder. Use the lead-free solder we have on the lab benches. Set the soldering iron temperature to around 715 Fahrenheit or 380 Celsius. Solder the 4 tabs on the USB-C connector to the PCB pads to secure the connector mechanically. Switch the soldering iron tip to a fine point. Use the 0.015 inch thick solder for the very small USB-C pins in order to avoid solder bridging. See the lab for this fine solder. Solder the 6 pins as shown. Inspect the pins under a microscope to ensure there are no solder bridges and that the pins are all soldered to the pads. Open the 2 SMD resistors from the tape and be careful not to damage or lose the 5.1 k ohm resistors. Using the thin solder, add solder to one pad of the 2 resistors. Using tweezers, reheat the solder and slide the resistors into the pads as shown. Solder the remaining pads to complete the connection. These 5.1 kilo ohm resistors tell the USB-C host to supply 5 volts. Now we are done with the SMD components. We will solder the through-hole parts in a way as to keep the profile of the PCB as low as possible. When soldering, it's usually a good idea to solder the smallest components first. Grab a resistor bender from one of the toolboxes. Using the 0.4 inch slot, bend the 1K and the 100K ohm resistors and place on the top side of the PCB. Ensure they are resting on the PCB and secured by bending the leads on the bottom side of the PCB. Flip the PCB over and tape it down. Solder the 4 leads and cut the excess off with wire cutters. Install the two 100 k ohm resistors, R3 and R4, in the same manner. R7 is a 0 ohm resistor, so just use one of the resistor leads you trimmed off from before. We will not use an 8-pin IC socket. Install the 555 timer and ensure pin 1 is installed where the pin 1 dot is on the PCB. Bend diagonal pins on the back to ensure the chip is as close to the PCB as possible. Solder one pin and check that the IC is still as low as possible. If not, reheat the pin and push the IC flat. When flat, solder the rest of the pins and trim the leads down. Trim the 2.2 microfarad capacitor leads off at the bend to allow for easy installation of the capacitor. To keep the PCB low profile, we will bend the electrolytic cap down to the PCB. Insert the capacitor and bend it down towards the USB-C connector as shown. Solder and trim the leads. We will install C2 similarly. Place the 10 nanofarad cap and bend it up towards the LEDs. Solder and trim. Insert the LEDs with the cathode or short lead on the right as shown. Solder one pin on each of the LEDs. Pick up the PCB and reheat the pin while pushing the LEDs flat. The LEDs must be flat to fit the case we will design for it. When the LEDs are flat, solder the other lead down and trim the leads. Your PCB is now complete. Carefully insert a USB-C cable into the USB-C port and press the button to test its functionality.